So we're continuing where we left off. We're finding the domain and range of this function. So again, to find the domain, you have to make sure what's under the square root is greater than or equal to 0. So that's what they've done here. So when you multiply both sides by -2, anytime you multiply by a negative, it switches your inequality. So now we have x minus 2 is less than or equal to 0. Adding 2 to both sides, we get our domain, which is x is less than or equal to 2. To find the range, first thing you do is set the square root, everything under the square root greater than or equal to 0. In this case, then we'll add 1 to both sides. And in this case now, this piece here is the same thing as our g of x. So g of x is our y, so that means our range will be y is greater than or equal to 1. So we've got two problems here. We want to find domain and range first. So working here on number 4, domain, we have to set what's under the square root greater than or equal to 0. Solving here, we'll get x is greater than or equal to 2, so that's our domain. To find the range, we take the square root and set it greater than or equal to 0. Then we do any multiplying, so we'll have to multiply both sides by -3. Well, multiplying by a negative, again, switches the sign of our inequality. Now we'll do the addition of 3 at the end. Add 3 to both sides. Now our left side of our inequality matches our original function, so we can replace it with y, and that's telling us that our range is y is less than or equal to 3. Plotting our reference points, we want to see what effect our function is having on those. So looking back, x minus 2 means we're going to be shifting to the right 2, so our x values will need to add 2. Then our y values will need to multiply by -3 and then add 3. So taking our original reference points of 0, 0, and 1, 1. 0 plus 2 is 2. -3 times 0 is 0, plus 3 is 3. 1 plus 2 is 3. -3 times 1 is -3, and -3 plus 3 is 0. So these are our new coordinates, 2, 3, and 3, 0. So our graph is going to look something more like this. Now this should make sense because we've got reflection with the negative there and a stretch of 3, so that's why it looks that way. Now we're fixing this one because we're not doing the horizontal stretch or compression, so we're just going to make it look like this instead. Our domain, again, we set what's under the square root greater than or equal to 0, which means that x is greater than or equal to -2. For our range, we take the square root and set it greater than or equal to 0. There's no multiplying going on here, so we'll just have to add 1 to both sides. And now the left side of our equation matches our original function, so we replace it with y. So our range will be y is greater than or equal to 1. Getting our reference points, our original coordinates, what's happening? We're shifting left 2, so our x values we subtract 2. We're going up 1, so our y values we add 1. So reference points 0, 0, and 1, 1. Get -2, 1, and -1, 2. So all we've done in this case is just shifted. Our graph is going to look something like that. Now, writing our function, if we're given the graph, again, the key thing you're looking for is that starting point. That's telling you where you're shifting. And then we want to compare how the y values are changing. So this is one we're not dealing with. We'll look at b here instead. So our initial point, hk, where it's starting is that coordinate -2, -1. Now comparing how the y values change, the x values change by 1 as we expect. The y values actually change by 1, 2, 3. That's our a change that we're looking for. We moved up to coordinate 2. So our k, which is -1 plus a is 2, we can just count this on the graph. We can see that a is 3. So that's our stretch. So our function will be 3 square root x plus 2 because it's a left shift, and then minus 1 because it's a downshift. Number 7. So first thing we look for is what's our HK point. In this case, we're at negative 3, 5. And then we look how the y values are changing. X values increase by 1 as we want, but the y values decrease by 3. So that means A is equal to negative 3. Since they're decreasing, it's a reflection, and then decreasing by 3 means we're going to have a stretch of 3 as well. So our function would be negative 3 square root of x plus 3 because it's a left shift, and then plus 5 for the upward shift. So we can do some square root functions to do some modeling, and then we're going to analyze a little bit of the relationships between the rate of change, or the slopes. We've got one worked out here for you. We're going to do this one together. So a car with good tires is on a dry road. The speed in miles per hour for which the car can stop a given distance d in feet is given by s of d is equal to the square root of 96 times d. So we're going to use some distances to come up with some speeds. So to find the speed here, we take root of 96 times 20, you get 43.8. For this one, we take the square root of 96 times 40 to get 62. Continuing on, if you plug these in, you'll get these values here. So we can graph these. Oh gosh, it's going to look something like that. I don't feel like taking the time to do that. You've got the coordinates up here. You can graph them yourselves. But looking here at, we're going to analyze the rates of change, or the slopes. We take the first interval, so the y values will be 62 minus 43.8 over 40 minus 20, gets us a slope of 0.91. And then looking at the last interval, we get 98 minus 87.6 over 100 minus 80, which is about 0.52. So the average rate of change is less for the last interval. It's a smaller number. The average rate of change represents the increase in speed with each additional foot of stopping distance. So as the available stopping distance increases, the additional increase in speed per foot of stopping distance decreases. So even though, what's happening? So as your amount of stopping distance increases, so as it takes you more time to stop, the additional increase in speed decreases. So before your speed is you can go faster with those stopping distances, but eventually you reach a point where your speed can't go much faster in order to get that stopping distance that you need.